Yep, there it goes.
We're recording! Okay, and...
Good afternoon, ladies and gentlemen.
Okay, stop.
What was that?
Okay.
Good evening, ladies and gentlemen. I'm Mike Keenan's Peak, and today we'll be seeing some of the mysteries of chemistry, to use the parlance. Now, what we have here, zoom in a bit, are some chemicals. A appropriate mixture containing sodium, aluminol mixture, sucrose, more sodium, and luminol, and copper sulfate, which has a very long scientific name, also edited from this movie. Now, this is a cup of ordinary water, and I would be willing to drink it, but I don't want to get my germs off the cup. So, to create a bit of light, which you will soon see in here, we are going to use something called the excited state of an electron. If you envision an atom as having a nucleus, this, here, then it is orbited by a number of electrons. As I'm sure you've seen before, it looks like a bunch of little planets. Well, it's not quite true, but it's a pretty accurate representation. Now, what we are going to do is we are going to cause some of these electrons to jump up to a higher state. They will orbit this way for a while, and then, when they lose the energy, they will fall back to their original state. And when they do that, they release a bit of energy, in this case, as a photon, which we will see. Now, let's watch the magic happen. The formula is fully scientific, has been proven many times, and will be proven many times again. But not on this video. Sufficient to say that the same process, or one similar to use it, caused the bioluminescence of fireflies and creatures which live deep in the sea, but we're not talking the thing that came from the depths of the ocean, or whatever those movies are called. Lights, please. Now, assuming all the proper quantities have been added, you begin to see a blue glow emanating from our cup of ordinary water, and now I would most definitely not be willing to drink this. Like so. Alright, lights. This will continue for some time, but it is not in our present course of discussion. You see, this is science, but it is not the scientific method. The scientific method is to create an experiment to test out a hypothesis. I write very badly. Perhaps we should do an experiment to test why I do that. Unfortunately, I have not had time to decide on the sociological one of that magnitude. Now, there is only one way in which this light can be created. For our purposes today, we will be using two common ingredients known quite well to every household mother. This is a little bit of baking soda. Rather stale, but baking soda nonetheless. And this is hydrogen peroxide, a very useful antiseptic, as I'm sure your mother will be quite happy to tell you. our hypothesis will be that we can create light with all of these elements, chemicals, formulas, whatever you wish to say, as our reactogens, but that one of them will create the most light. Now, the reactogen, which we've just seen working at work, is the copper sulfate. In some cases, and in some cases, we are substituting for the luminol mixture. Now, where did I put that? So, to form a good hypothesis, we will need to have an opinion. And while opinion is not particularly scientific at this stage, it is a good idea. But I leave it up to you to decide which of these reactogens you think will create more of the cool blue light, which you've just seen, or whether the original formula is the most successful to these ends. Now, to continue the experiment. We add in 2 small scoops of baking soda. But in this case, only a few drops of hydrogen peroxide. And since I'm using this peroxide a bit illicitly, it's probably a good idea for my mother's sake. There's not much being used. Now, stir them up a bit. It's always best to have a solution rather than simply chemicals floating around loose. This one, can we have the lights off for a second? Alright, this one has mostly stopped now, lights. But the solution now requires only a bit of the more reactive substances, copper sulfate and aluminum. Alright. Now we'll go down the line. A bit of luminol mixture into this. A few copper sulfate crystals lights. Well, perhaps not as bright as it was before. Let's try a bit more substances. That's a bit better. Still. Now, into the baking soda. Lights, please. This is the handbook, which is definitely the friend of all scientists. In this case, I have to show you it to prevent a label of plagiarism. Also, as with me, if you need notes and have a bad memory, this is also your friend. Alright, lights. Now, into this one. We put some perborate, a few copper sulfide, luminol. Bit of a greenish hue, and not particularly bright. But still definitely there. Into this one. A few copper sulfate crystals. And a dash of luminol mixture. Again, more greenish than we're used to, but nonetheless, fairly admirable. Now, we have seen all these, and our conclusion is that neither of these reactors are perhaps quite as effective as a combination of all the elements put together. Lights. Our conclusion then, that we can draw from our conclusion, is that people who put this kit together really wanted you to get a bang for your buck and gave you some of the most active ingredients that were still fully safe that they could give you. Interesting colors now, aren't they? Alright. That's all for today, since I'm not going to teach you about waste disposal. Now, if you ever want to envision an electron, envision it as a magic act. You see, when it goes from this state to the excited state, there's not really a transfer of time in between, where it's somewhere in the middle. It can't be in the middle. It goes right from one directly to the other. So while you would see this ball roll off, the electron would roll off simply by jumping from the one spot to the other spot. That was studied in something called quantum electrodynamics. And this wraps up our science video. Thank you, ladies and gentlemen. Good enough.